Now it's time for you to try these problems on your own. So download the documents from the description and try to work these problems out by yourself. If you get stuck or you want to see how they're done, I'm going to solve all of these problems and show you how to do them. So we're starting with a 500 kilogram block with a force of 45 newtons at this angle of 65. And the question is, find the horizontal component. So we're looking for this, the horizontal component. So I'm going to redraw this here, 45 newtons, and I'm going to draw my right angle of 65 degrees. And we know that that's a right triangle, and we're looking for this horizontal force. So we're going to call that Fx for force in the x direction. And we have the adjacent and the hypotenuse. So that's going to be cos theta equals adjacent over hypotenuse, or cos 65 equals f of x over 45 newtons. And we have cos 65 times 45, and that gives us 19 newtons. Okay, we have a hiker, starts at point P, walks 2 kilometers east, 1.4 kilometers north, and the diagrams here is to scale. So it says, using a metric ruler, determine the scale used in the vector diagram. Now, we could do this for either vector, but I'm just going to choose the one that is 2 kilometers, and I'm going to put my ruler down here and lining that up. That's about 6.6 centimeters. So 6.6 centimeters is equal to 2 kilometers. So if we divide 6.6 over to the other side, that's going to be 1 centimeter is equal to 0.3 kilometers. So we just answered the first question. On the diagram in your answer booklet, use a ruler to construct the vector representing the hiker's resultant displacement. So they started here, they ended there. This is already set up for us in the tip to tail method. So all we need to do is draw our resultant and make sure our arrowhead is right at the tip of that other arrowhead. Determine the magnitude of the hiker's resultant displacement. We have two choices. We could do Pythagorean Theorem to find this, or we could use the scale. Let's use the scale. So we measure this. This comes out to 8 centimeters. So if we have 8 centimeters multiplied by 0.3 kilometers per centimeter, that's going to be 8 times 0.3, and that's going to be 2.4 kilometers. And then finally, find the angle. We could use tangent with our two sides, or we could just extend this line out and find the angle this way. And that looks like that's about roughly 35 degrees. Number 3, the scale diagram below represents two forces acting concurrently on point P. So this is what we've got here, two vectors. And the first question they're asking is to determine the linear scale used in the diagram. So to do that, we're going to measure the length. That's 10 centimeters to there, and that is about 0.8 centimeters. So we have 10.8 centimeters for the length of that vector. Now, we could have done that for the other vector, but it doesn't actually make a difference. So we're saying that 10.8 centimeters is equal to 32 newtons. So if we divide the 10.8 over, so we have 32 divided by 10.8, we have 1 centimeter is equal to 2.96 newtons. Okay, so part 1 completed. Next, basically find the resultant between A and B. So they already did the angle for us, so they did a bunch of the work. So what we need to do next is to draw this vector, but we've got to slide it up here. And to be able to do that, to slide that up, it needs to maintain the same angle. So what we're going to do is put our protractor down like this. And we're going to come over down to 120. And as we've done before in these problems, we don't know the magnitude of that, so we can't draw our arrowhead until we found the length of this vector. So I'm going to measure this, and that looks about 6.7. So we're going to come down here. .7, and now we can draw that vector in like that. We can connect these to finish our parallelogram. It's actually not necessary to do this, but and now we have our beginning of the problem and our end, so that is our final resultant that we're looking for. Okay, so we just did part 2. Part 3, determine the magnitude of the resultant force. Well, we know that 1 centimeter is 2.96 newtons, so let's just measure the length of this vector. And that looks about 9.4. We have 9.4 centimeters times 2.96 newtons per centimeter, which gives us 27.82 newtons. Problem 4. We have an airplane traveling north at 220, and there's a 50 meter per second crosswind from west to east. What's the resultant speed of the plane? So we have a vector that's going up at 220 meters per second, and a vector that's going 50 meters per second, and they're looking for the resultant. So we make our rectangle, and we know our resultant is up to that corner. And this problem, we can just do Pythagorean Theorem. We know this side is the same as this side, 220 meters per second. So that's going to be a squared plus b squared equals c squared. So that's going to be 220 meters per second squared plus 50 meters per second squared equals r squared. And if we do the math on that, that comes out to be 225.6, or roughly 226 meters per second. So that is answer number 3. Let's look at question number 5. The components of a 15 meter per second velocity at an angle of 60 degrees above the horizontal are what? So we have a vector that's at 60 degrees, and what they're looking for are the components. So if it's going up and to the right at 60 degrees, we draw in our rectangle. So we're looking for this. That's going to be our Vx, our horizontal velocity. and our Vy, which is going to be our vertical velocity. And this right here is our resultant velocity. So this is going to involve sine and cosine. Our adjacent and hypotenuse are going to be cosine, so that's cos 60 is equal to adjacent Vx over our hypotenuse, which is V, which is our 15 meters per second. And so we do cos 60 times 15, and that ends up giving us Vx as 7.5 meters per second. To do the vertical component, Vy is going to be equal to this side right here. So we have our opposite and our hypotenuse, so we're going to use sine. So sine 60 is equal to opposite, Vy, over hypotenuse. Here's our hypotenuse of 15. And sine of 60 times 15 gives us 13 meters per second. So when we look at our choices, we have a vertical component of 13 and a horizontal or x direction of 7.5. This problem has a diagram, and I downloaded this problem from an old Regents problem, but the diagram is not perfectly to scale. So I'm going to solve this based on this diagram, which is actually different from the diagram that was used on the Regents by about 1 centimeter or so. So this will be my solution based on this. So we have this girl who goes for a bicycle ride. She goes west 1.4 kilometers, then she goes south 0.7 kilometers, and this one's a little different from the other problems that we've seen. She then travels back east 0.3 kilometers. And the first question says, on the diagram, using a protractor and ruler, starting at the arrowhead of the second displacement vector, draw a vector to represent the 0.3 kilometers east of the east displacement. So we've got a couple of things to do first. First, we have to recognize that she went west, she went south, now she's going back east. But before we can draw that, we have to figure out how far that is. So she's going 0.3 kilometers. And we have 1 centimeter per 0.2 kilometers. That's the scale that we've been given. So if we divide, kilometers cancel, and we're left with 1.5 centimeters. So before we can draw this eastward vector, we have to make sure that it's perpendicular. But as we've seen in the past, I can't quite draw this at 90 without being able to line up the edge of this protractor with a line that goes off of there. So the only thing we can do is draw a line in here so we have something to line up the protractor off of. So now I'm going to take this dot in the center and put it right there in the center of that. And now at the top I can line this line up so I know I have a 90-degree mark over here. So now I'll draw this as a faint line. And we know for a fact now, because we used the protractor, that this is a 90-degree angle. We determined that the eastward vector has to be 1.5 centimeters. So we're going to come down here and we're going to go out 1.5 centimeters. Okay, and it says label the vector with its magnitude. So we're going to write 0.3 kilometers. Okay, Part 2 was to figure out her average speed, but because we haven't done speed and velocity and kinematics yet, we're not going to do that part, and I didn't include it in the practice problem sheet. I deleted that question. Determine the magnitude of the girl's resultant displacement for the entire bicycle trip in kilometers. So, where did she begin? Here. Where did she end? We have the tip-to-tail method. The only thing that's different from this, from other problems that we've done, is that this has 3 vectors, but the rules remain the same. It's the tip-to-tail method. So we start at the tail, and we end at the arrowhead. And now we have the resultant R. But the question said in kilometers. So we need to measure how many centimeters that is. We'll say about 7.4 centimeters. But there's 0.2 kilometers per centimeter. So we have to do 7.4 centimeters multiplied by 0.2 kilometers per centimeter. So 7.4 times 0.2 gives us 1.48 kilometers. Our centimeters cancel there. So the resultant is 1.48 kilometers. Our last question here is determine the measure of the angle in degrees between the resultant and the 1.4 kilometer displacement vector. Okay, so here's our resultant, and here's our 1.4 kilometer vector. So we're trying to find this angle in here. So we can line this up with point P, and we can come out here 10, 20, 30, and we're at about 32 degrees. A number of 1 Newton horizontal forces are exerted on a block on a frictionless horizontal surface. Which top view diagram shows the forces producing the greatest magnitude of acceleration? So to find the greatest magnitude, we need to find the greatest resultant. So we can first start out actually with choice 4 and realize that we don't have to worry about this one because they're all going to cancel each other out. The vector sum of this is 0, it's in equilibrium, so we know it's not that one. And we also know it's not this one because these also cancel out to 0. So let's look at these 2 vectors. This one is going to cancel with this one, so the vector sum is going to be 1 Newton. The vector sum of this is going to be this vector and this vector combined, producing a new vector out here. And this new vector, in vector addition, has to be larger than these individuals because they're at right angles. Now, we could do that using a squared plus b squared equals c squared to prove it to ourselves, but you can see that just from the diagram that this vector has to be longer than this. And because this vector is larger than 1 Newton, it's also larger than this vector. So the answer is 1.